Dear colleagues, allow me to present to your attention a report on the topic: synthesis of thin film layers of electrochromic panels based on tin oxide and tungsten oxide by aerosol pyrolysis. An electrochromic panel is a semiconductor device based on glass. The parameters of smart glass can change under the influence of the following external factors: sunlight, temperature. In the case of electrochromic panels, this is an electric current. Smart glasses are usually subdivided into two types: automatic and controlled. Automatic glasses are characterized by a change in parameters under the influence of environmental factors, including lighting. The properties of controlled glasses are influenced by electric current. The most common in the production of smart glasses are electrochromic and thermochromic materials. The main oxide materials for use in electrochromic panels are transition metal oxides and transparent conductive oxides. Transition metal oxides are inherent in semiconducting properties and catalytic activity. In this case, the optical contrast, color efficiency, response time significantly depend on the amount of oxidized or reduced metal ions, color centers, as well as on the kinetics of redox reactions. Electrochromic redox reactions of the TO imply the following: the phenomenon of charge transfer. At the interface between the TO and the electrolyte, a redox reaction controlled by ion diffusion in the TO lattice. The main oxides of transition metals include, for example, oxides of titanium, tungsten, molybdenum. Transparent conductive metal oxide has high infrared and visible transmittances. In order to increase the conductivity, it is necessary to dop the material. By embedding in oxygen vacancies, the impurity allows an increase in the number of free charge carriers of the synthesized structure. In addition, the material is characterized by high transparency in specific ranges of light radiation. The transmission region of the coatings is in the wavelength range from 400 to 1500 UHz. Now we will study the synthesis of tin dioxide doped with antimony. The structure of the spray pyrolysis system is presented on this slide. Tin dioxide doped with antimony, or synthesized by aerosol pyrolysis, is also used as a conductive layer. The solution is made on the basis of tin tetrachloride pentahydrate, antimony trichloride and ethyl alcohol as a solvent. The coatings were deposited on a clean calcium soda silicate glass substrate at a temperature of 450. When using different amounts of dopant, the transparency and resistance in the visible region of the light spectrum were 93% and 27 ohm, respectively. You can see this in the graphs presented. It is shown that the impurity concentration has the main effect on the above indicators. Samples of antimony, tin oxide and tungsten oxide were synthesized experimentally by spray pyrolysis. A number of coating parameters that are essential for use in electrochromic panels have been investigated, namely response time, staining efficiency, conductivity and transmittance, transmission capacity. The extended article also presents the study's results of the carrier's mobility, mean free path and Fermi energy of transparent conducting oxides, dependence of the parameters of transition metal oxides on the fraction of surface atoms. The main stages of a film of tungsten oxide obtaining process are considered below. First of all, a solution, which includes ammonium paratung as a precursor and polyvinyl alcohol, is prepared. The deposition of an electrochromic film is performed on a substrate with a pre-applied conductive layer. The coating synthesis temperature is from 300 to 450, since this range is most acceptable for obtaining a high-quality coating, which is confirmed by the results of their studies. The electrochromic parameters of the synthesized films were characterized by a high staining efficiency and a fast response time, which is 7.6 s and 4.2 s, for staining and discoloration respectively. Thank you for attention. Our contacts for scientific cooperation are presented on the slide.